Now in the previous video we did basically an overview of how you can find all the angles here. So now in this one we're basically answering the questions that follow. So let's go ahead and do that and start with the first question. Now the first question here says, now let's prove that KQ is what? KQ is tangent to the circle LQW. So how we're going to do it here is that if we're saying now KQ is tangent to LQW, what you're going to do is you're going to first look for KQ. So you're going to draw KQ. So let me draw KQ, right? And then after you've drawn KQ, you're going to look for LQW and draw that angle also. So LQW. Now if you remember when we were doing the writing all the angles, we said that whenever you're talking about the tangent, you should look for tan chord, and you should also look for radius perpendicular to tangent. And other times when you have two tangents, you're going to look for two tangents that they intersect at a common point. But in this case here, you can see here we don't have much. Here we can see that the only way that KQ can be tangent to LQW is if this part Q3 is the same as W1. So basically what we're going to do now here is, here we're going to see that if you can prove that Q3 is the same as W1, then it means you can prove that KQ is what? Is a tangent. And not only that, we can prove that there's a circle that it passes through L, Q, and W. So to do this, we're saying now here we want to prove that Q3 is the same as W1. So we're going to go into the information and see what did they say about Q3. So looking into the information that we had, we're going to look for Q3. So let me look for Q3 here. Q3, where are you? Q3, there it is. There you go. Q3 was equals to S. Now the reason for that was that we had alternate angles where line PQ was parallel, PS was parallel to QT, right? There is the lines parallel, PS parallel to QT. So which means now to answer the first things first, we're going to say Q3. You're going to say Q3 is equals to angle S. And then the reason there that we got was the alternate angles. Alternate angles equal where PS parallel to QT. Now do you see how easy we got that one? And then after that, we know what is Q3 is. It is S. Now we're going to look for W1 and see if we have then another equation or another information where it says W1 is equal to something, right? So let's go ahead and look there. So let's check here first. All right, there it is. W1 is equals to S, right? So we can see here that W1 is equals to what? Is equals to S, right? Now what's the reason for that? The reason for that, it was the angle in the same segment. So do you see how easy that one? So here if Q3 is S and W1 it is S, this basically means that Q3 is the same as W1. And like I said, if you can show that Q3 is the same as W1, then it means what? KQ is tangent, right, to circle LQW. Then the reason for this is going to be the tan chord theorem. Now I know some of the people, they're gonna say no, but there's no circle here. Now in Euclidean geometry, if you can prove something like this, tan chord, then it means there is a circle there, but it's not shown there, right? So basically here you don't need to question more things, or you don't need to overthink it. You just need to keep working with the properties that we know. So here, just like you see here, as you can see here, we use the property of a tan chord to prove that if there was a circle here, and we said KQ was a tangent, this was going to be true if Q3 was equal to W1. Then we just proved that is true, so it means there is a circle, because we said in the statement if there was a circle. So I hope this makes sense, but let's go ahead and look into the second question, where they're asking about another question to prove. So 5.2 says prove that R1 is the same as L3. So just like we did in the previous question, we're going to first underline this one. So we're going to pretend as if they are equal, right? R1 is the same as this one. So basically, we want to go into the information that we got there and see what we got for R1 and L3. So first things first, we want to start off with R1. R1 here, I can see that, there we go. R1 is the same as Q2 plus Q3. And then the reason for that was alternate angles. So what I'm going to do is, I'm going to go back there into the question and say R1 is equals to Q2 plus Q3, right? And the reason for that was alternate angles that are equal, right? Alternate angles, let me just write this correctly. Alternate angles equal where PQ is parallel, PS, not PQ, PS parallel to QT, right? Alright, so now I have my R1, but I need to find what is L3. So if I'm looking there for L3, where is L3? L3 here, L3, there is L3. They said L3 is the same as R3, same thing, alternate angles. So basically, we're gonna go back there and then say L3, it is equals to R3. Now basically, we want to change or want to simplify L3 such a way that we get we're getting what? Q3 and Q2, right? Q2 plus Q3. So here we're starting off here, alternate angles equal, we again PS parallel to QT, right? So now basically we know what is L3, it is QT. So let me just put this one. Now it is R3, but now let's look at what is R3 here. So R3, if we go back into the information, R3, except for this one, R3, where is R3? Let's just see. Alright, let's see. There we go. R3 is the same as Q3 plus Q4, right? R3 is the same as Q3 plus Q4. So here R3 is the same as Q3 plus Q4, and then the reason for this is the angle in the same segment, angles in the same segment, right? In the same segment, which means now we back here. But now do you see what's happening here? I can see that R3 has Q4 and Q3, and then now it means here Q3 is basically what it is. It's in R1. Now I just need to look for Q4 here. What is happening to Q4? So I'm gonna go ahead and see that is there any angle that is equals to Q4 and see if it's Q2 or not, right? So now what I'm going to do, I'm gonna go back into the information. I'm just looking for Q4. There we go. Do you see how nice this is? Q4, it is the same as Q2. Do you remember the reason? We said equal sides equal angles. So this then means that Q4 is the same as Q2, right? The reason, equal sides equal angles, and so this means that R3 is going to be Q3 plus Q2, or you can write it as Q2 plus Q3. So this then means that if R3 is Q2 plus Q3, and then we know that R3 is the same as L3, it means L3 it is also Q2 plus Q3. So L3, let me just highlight this, L3 is Q2 plus Q3 and R1 is Q2 plus Q3, then means they are both equal, right? And that's how we have proven our answer. Now do you see how this thing gets easier? Because I know some of you, they might have a problem with how we're taking out all that information and then thinking about time and whatnot. But in Euclidean geometry, most of the time it is spent finding all the angles before you even go to the answer. So if you can get all the angles that are necessary for you to solve, then it won't be difficult for you to answer these questions, and it's going to be faster. So let's go ahead and look into the last question. Prove that PRKQ is a cyclic quadrilateral, right? So P, so we're going to go draw that one. PRKQ. All right, let me just clearly draw this one. Just stay at the top of the line so that I can see the angles. All right. Almost there. And then let's join PQ. Oh, sorry, that is join PQ. There we go. Right. So now here they're saying we need to prove that PRKQ is a cyclic quadrilateral. So now if you remember, in a cyclic quadrilateral, we said that whenever you're looking for cyclic quads, we're looking for these shapes, right? If you remember, we said it's this shape one, right? And this one, and this one, right? So basically, for us to prove that something is a cyclic quad, we first need to check if the quad inside is it in this shape. Is it the quad like that, or is it the quad with an exterior, or is it something that is going to be a butterfly? So what we're going to do here, we're going to come then into the question, and then when we get into the question, I can see that okay, PRKQ already is a quad, but I can see that in this part here, I can see there's an extension here, right? There's an extension here, and also on that part there's an extension there, right? So why am I writing these extensions? I'm writing them because I can either show this by calculating whether K1 is the same as Q, or I can show this by calculating R3 and show that R3 is the same as Q1 plus Q2, right? So I can choose either of those, right? So here what I'm going to do is I'm going to go ahead, first things first, I'm going to look for the idea here to prove that. So I want to take one of these, and taking one of these is going to be I want to take this one, K1, right? So here I want to show that K1 can be the same as P, right? So what does this mean then? It means now I need to look for anything that has to do with P or that has to do with K1, right? All right, so I'm going to start off with let me start with P. Let me start with P since it's outside there, right? So when I look for P, so let's go ahead and look for that one. Now if you remember back where we had we didn't have P. I don't remember having P. All right, let me see, but we should have it. Yeah, there we go. If you remember back there, we said P plus Q1 plus Q2 plus Q3 was 180, and then the reason for that was co-interior. So that's how we're going to start this one. So we're going to say P plus Q1 plus Q2 plus Q3. This was equals to 180. Then the reason for this is co-interior, and then where PS parallel to QT. So this then gives us P as 180 minus Q1 minus Q2 minus Q3, right? So we do have P, and then now we need to find what K1 is. All right, so now what we're going to do is we're going to look for K1 and see if we have K1 there in the information, because we have calculated what P is, but I don't remember having K1 there. Yeah, no, we don't have K1 here. So because of we don't have K1, basically what we're going to do is we're going to look at the K1 and see whether it is in a triangle or what, right? So here I can see that K1, if I'm looking for K1, let me just highlight this one. We're trying to find K1 now. Okay, so let me remove this one since I'm focusing on this one. So K1, I can see that K1 it is in KQW. So sometimes when you don't have the angles in the information, just look for it in a triangle or as an exterior. Alright, so now looking into that triangle, which is triangle KWQ, I can see that K1 plus W1 plus Q3 plus Q4, it is 180, and that is the sum of interior angles of triangle. Alright, so this then means now K1 is 180 minus W1 minus Q3 minus Q4, right? Alright, now here the problem here is that in the value for P, I only have Q1, Q2, Q3, but now in K1 I have W1 and Q4. So the good thing is that I do have 180 minus, and I have Q3, which is minus Q3, not just any Q3. I have minus Q3, and also I have minus Q3. So it means here I need to show that W1 and Q4 can be written in one of these, right? Now if you remember W1, let's see W1 in the information there. If you remember, where is W1? W1 was the same as Q1. Do you remember that one? This one? W1 was the same as Q1, and I think we have already showed it in the question here. Where is it? Okay, so let's just show it. Here. W1 is the same as Q1, and the reason for this, it is tan chord theorem, and then this then means that now we do have Q1, which is that one, and then now Q4, if you remember Q4, we did Q4 is Q4, we said Q4 was Q2. Q4 is equal to Q2, so this was proven in 5.2. So this basically means now K1 can be written as 180 minus Q1 minus Q3 minus Q2, because now we do have the value for W1. It is W1 is Q1, and then now Q4 it is what? Q2. So it means now we can just substitute that. But now as you can see here, the answer to get for K1 becomes the same as the one we have for P. So this then means now P is the same as K1, and then because of P is the same as K1, it means now P R K Q is the cyclic quad, and then here this is the converse. This is the converse of the exterior angle of the cyclic quad. Let me just write it CQ. And that is all for this question. I hope this question you liked it and it also made sense to you. And also I'm gonna leave you with this one. Whenever you're doing Euclidean geometry and similarities, by the way, it is important that you understand the information and the diagram before you can even go to answer the questions. If you miss this step where we were talking about the angles, all these angles given in the information and the glossary, means you're just going there without even knowing the purpose or the tools, without even have the tools for you to find that question, which means it's going to be very, very difficult for you to prove even the similarity angles or to prove anything. So I hope that makes sense. And so that's all I got for you today. If you liked this one, just make sure that you share it with your friends, and please make sure that you take all the notes and you understand everything that you have done there. And I'm going to see you on to the next one. Cheers.